Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, guys, this is really interesting footage. Now, stereo Sechi satellite stereo H1 is a NASA satellite, and it's designed to view space in light energy. And when I say light energy, I mean protons and plasma. Now, very quickly, just take you to their website, and from there we'll understand very quickly. There you go, stereo GFS NASA Gov, right? And this explains how the instrument actually works, the instrument that we're going to watch a video on. This is really important, especially for our beloved ulama ikram, because I think, and Allah subhanahu wa ta'ala knows best, but I think that we may be seeing one of the Malaaika, the angels, shielding the earth back in 2007 in space, using its form, and you can see something that looks very clearly like a wing, right? As conventionally depicted on angels, subhanallah, is very ajib and very interesting. And scientifically, this instrument basically looks into space, not using what conventional lenses, camera lenses. Now we'll just very quickly read this so that we understand everything. Okay, the instrument, the plasma and superthermal ion composition, abbreviated as plastic. Okay, instrument is slated to study coronal solar winds and solar wind heliospheric processes. Plastic will provide in situ plasma characteristics of protons, alpha particles, and heavy ions. So this is what it basically looks at. So everything that you see falls within this scope and nothing but. So there's no such thing as lens flares or anything like this by this camera, because it's picked up in the radio wave frequency. It will supply key diagnostic measurements of mass and charge state composition. So you've got the negative and the positive charge state, plus the mass, the size of that particular negative and positive charge state composition of the heavy ions, and will characterize the coronal mass ejection plasma from ambient solar wind plasma. The University of New Hampshire and Tanat Galvin is the principal investigator for plastic. Stereo waves is an interplanetary radio burst tracker, okay? A radio burst tracker that will trace the generation or evolution of traveling radio disturbances from the sun to Earth's orbit. A radio and plasma wave receiver, okay, is both remote sensing and in situ instrument. Milan Maximovic, okay, from Paris Observatory, Mudon, in the true principal is the true principal investigator. I will leave this link as well so that you can read it again. But let's go back to this. This is very subhanallah. It's very ajib. It was posted today, the 29th of March, subhanallah, and I want the ulama ikram to see this, because remember I said I started having my dreams in 2007, subhanallah, right, about the system having arrived and the star Najm Thaqib having arrived. I can't make this up. This is from NASA, right? And what we see is this satellite which picks up in frequencies in the negative and positive charge states, right? And in protons, in light. Everything you see over here falls within those categories that we just discussed right now. And this is very ajib. Let's listen to this gentleman, what he says, and see the apparition that comes into the frame. Subhanallah. Allah subhanahu wa ta'ala knows best, but it's very interesting, to say the least.
Came across
So I'm assuming to protect, if it is indeed a Malaaika, then Allah subhanahu wa ta'ala commissioned the angel to protect the earth, or for whatever reason. At least what we see is a coronal mass ejection coming out from the sun, and then this apparition appearing from almost nowhere, subhanallah.
Something. Well, actually, I've come across quite a bit. So this is going to be the first in a series of what we're going to call What in the World Was That? So let me set the scene for you here. This is January 1st, 2007. Yes, turning back the hands of time. So put yourself where you were in 2007, January 1st, and let's see what was happening in our solar system. Just to let you know that I've slowed this down to 20% of normal, because I believe what you're going to see is, well, I'll let you see. So here we come. This is Venus, Birkeland current, right?
By the way, guys, this can't be doctored. I need you to understand that. Okay? As in, whatever's available by NASA, I mean, certainly it can be doctored by NASA. So, I mean, that's another thing that we need to consider is the possibilities. But outside of NASA, once it's made available publicly, there's not very much that can be done in order to CGI or manipulate this footage in any shape or form. And even if it was done, it'd be very blatantly obvious that it has been done. This is the file, the raw file, as it is provided by NASA from their platforms.
Going across. What is this? Are you kidding me?
Okay, guys, what I want you to look at, SubhanAllah. Okay, first of all, this wing, right? We'll look at that carefully, SubhanAllah, in a second. Do you see this black line going through? That is Venus we're looking at, and that's what we call the Birkeland current. Okay, there's a scientific individual who basically, a scientist who basically came out with this theory about the Birkeland current, and it's a very, very real theory. And in that, what happens is when you have this, the negative and positive polarities, which we have, even the Earth has that, all this planetary celestial bodies have it, where you have this negative and positive current, which will go vertically through from the North and the South Pole all the way out into space, right? Now, that's the Birkeland current for a planet. Do you see that black line? That's a Birkeland current for a planet. A planet. This is the Birkeland current for whatever apparition that we've just seen right now. Remember the angstroms and how in radio wavelengths this particular satellite functions and picks up. So what you see in footage is done in radio wavelengths, not in conventional terms of images, okay? So understand the science behind that, and I will leave a link behind. But you see the width of that Birkeland current? Just imagine how many, SubhanAllah, how many Venuses would fit into that. That Birkeland current is something I have never ever, since I've been studying this phenomena, I've never ever seen a Birkeland current like that. That wide, that large. And again, we've been told that Malaaika is so big, SubhanAllah. Some of the Malaaika, as we have been told, if they were to stand, then their feet would be on earth, and then their torsos would be up in heaven, SubhanAllah, right? And we're talking about the samawats. And Ajib, SubhanAllah, that one of the angels will told, SubhanAllah, Israfil alayhi salam, that if one teardrop was to ever fall down to earth, then it would we would basically experience the deluge of Nuh alayhi salam, the floods of Nuh alayhi salam, right? That's how great, how large and how majestic and how great these beings are, these light beings that Allah subhanahu wa ta'ala has created from Nur, subhanallah, from light. And this is just very possibly an angel, and Allah subhanahu wa ta'ala knows best. At least it's a possibility. And if it's not, then we need to ask, what is it, and why would NASA, this is a very scientific instrument, a satellite, why would NASA then want to basically fool the public, or at least the academic demographic, into considering the possibilities of what it really is? Ya Allah, subhanallah, look at that. I mean, really? Allahu Akbar Kabira. If it is, then I can't even begin to explain to you my excitement, because that's Venus. And that possibly is one wing.
The world is this? Are you believing this? Now, I have taken stills of this. Now, just to let you know, this is Mercury. This is Venus, and I'll show you this on a solar scope so you can see it. There's the sun doing its normal on a CME. So we're going to go back because this is just remarkable, folks. When you really take this in, what is happening? I don't know what this is. Whatever it is, it's huge. It's bigger than any planet, almost bigger than our sun. And I'll stop it here so you can really get an idea. Now, understand, this is a Berkeley.
Not almost bigger than our sun. It is bigger than our sun, guys. And that's whatever that apparition is. SubhanAllah, it's bigger than our sun.
Current.
This is science, by the way, guys. We're not
coming off of this.
This is science. Yeah, we're not looking at some sort of image from a Hollywood studio camera set or some sort of CGI. And this is a scientific instrument which is in space and which looks at space in the radio wavelength and not necessarily the visual wavelength, right? So what we see over here are negative and positive particles, charged particles. So whatever's lit up white is positive, whatever is lit up darker is negative, and then you get to appreciate the mass of that particular object as well, subhanAllah. Okay?
Here's this poor little Venus out here, which we have seen of lately because it's been so bright, but nothing in comparison to this. Look at this, folks, and we're going to go through some.
And this anomaly as well. Allahu Alam. I mean, look at the size of it, right? Look at the size of this, and this anomaly we've seen consistently. Now, I'm assuming it's one of the gas giants. Allah knows best. But for some reason, this transparent anomaly seems to be captured almost everywhere in our solar system by these instruments for a very, very long time. And it perturbs a lot of us. It has been hijacked by other individuals. They're calling it all sorts of stuff in extraterrestrial nature. I certainly don't believe that, but Allahu Alam, what it is, I'm yet to get to the bottom of that. One of my positions is that it's actually one of the gas giants, and they're doing their best to occlude it, but somehow we're picking a translucent footprint of that gas giant because they're not being able to totally remove it from their instruments.
Stills and just try to get an understanding. And also, let me give you a little background more on this. So,
by the way, when I say one of the gas giants, I mean one of the gas giants that's come in with the star system of Najm al-Thaqib, right? The primary star, the neutron star. So we've got two stars, the brown dwarf star, and Najm al-Thaqib, a neutron star, which is the primary star, the patriarch of this binary star system. And this potentially could be any one of the celestial bodies orbiting and following that star system, which doesn't really belong in our solar system.
They launched this bird up in 2006. And they first got the first pictures in December, which I do have those, and I will show those in another program. So this is like, here are the engineers and all the guys working at JPL and the Marine Observatory, and look at this. They're seeing this. Look at this, folks. It's huge. It's huge. Look at the light signature of this. And I have never seen a Birkeland current anything to the size. This is so far off the scale, it's beyond imagination. But look at this. I mean, it is just incredible. Look at that. This is the sun right here. And look at this. Is this just amazing or what? And look at this. Now, we've got this also from another angle, and here comes Mercury. And I will show you on solar scope so you can understand what we're seeing here.
This is literally a wing of light. So we're talking about a wing that's made of nur, of light, right? Because this is the wavelengths and that this particular instrument picks images from. Okay, so it looks at protons and interprets those particles into negative and positive, and you'd see that in white and black. What we saw is something that was eerily similar to the conventional understanding of what a wing on an angel looks like, subhanallah, and as most of us visualize it to look like as well, subhanallah, is what we just saw right now, but in the light spectrum, right? So it wasn't like anything else, but it was light. It was nur, subhanallah.
And, you know, there has been a lot of debate as that this is a lens flare. It is not. I can tell you that you go back to the very early pictures and you begin to track what's happening to Venus here. And it only happens to Venus. Only. Venus gets this, I don't know what you want to call it, ejecta, halo, whatever. Look at that. Now you can see both these planets, same thing, same Birkeland current, right? Yeah. All right, now take a look at this. Okay, so this is at the same speed, 20%. Now, this is, again, stereo A, HI1, and you can see this one here takes the negative and positive. Look at this, folks.
Subhanallah.
Is this just amazing? And look what it's doing to Venus down here. I mean, Venus is just going crazy. Look at this. I don't know what this is. It can't be a planet. Something this size had to have been observed. Look at this. My impression when I saw this, by the way, is that I saw, you can almost say this is like an eagle's wing, maybe even an angel's wing, right? I mean, but it's huge. The scale of this, even if this is close to the camera, and I'll show you where these satellites are positioned, it's still, number one, very bright, very large, and it took days to pass through our solar system. Look at this. And you can see our sun's reacting. Our sun is just reacting big time on here. And then here comes Mercury, and I'll show you how we know that. Look at this, and our sun is just reacting. And if you notice here, you can actually see that this is, that's why I know it's particles. And you can see it as though it's kind of like on water, but this is out there in space. So this is all part of the wake of whatever that was. And then you can see, again, these are particles. Something with Venus. And if you notice too here, let me show you something. Mercury, right? Venus. Mercury, Venus. Do you see a difference? Yeah. Even as you continue to see, now here's a huge coronal mass ejection, a CME. And there's Mercury right here, and here's Venus. So if this was a lens flare, right, that would come off of Venus, this is what they're saying, a planet, we should be getting the same effect here with Mercury. I mean, unless the properties are different. All right, look at that huge CME. All right, so let me show you where these satellites are at. So here you go. Stereo A, stereo B. We were looking at stereo A. So it's looking back this direction, in which you're going to see many times Venus and Mercury in this configuration. Now, this is solar systems scope, and as you can see, I've got the time. This is set in to January. So this is January 23rd, the same time that we're watching whatever this was. And so what you're going to get the view, let me get this right, would be this view right here. So there you go. Now, it can't be Mercury. We see Mercury and Venus. Whatever this was came in, and we're going to see it one more time, but I just wanted to show you that I'm doing my best to try to see what could that have been. We know it was no planet. I've never seen a planet, and if that was the comet, holy crap. I mean, that has to be the largest comet I've ever seen. So I just thought we'd go through a couple of stills so you can see what happened here. And when you see what's going on, it's just incredible. It really is. So here we go. Comes the sun. Well, that's a weird looking face, isn't it? I hadn't noticed that. Now, again, look at Venus, right? Important. Birkeland current, notice the line. Look at that. You know, when you begin to measure this in scale, well, maybe some of you watching this will get your estimates, but mine are, this was huge. Look at this. And all I did here was just take it into reverse the fields here in light. It's just huge. Absolutely enormous. It's so big that this Birkeland current line, right? This is Venus. Look at this. And even if you take the fact that, let's say, the spatial, where the camera is seeing that this is, let's say it's passing close by.
Again, guys, just as a reminder, the Birkeland current is the positive and negative polarities, right? We have it as well. It's the Taurus energy. Insan have it, you know, mankind, humanity, we have it, and it basically resonates from our heart, SubhanAllah. The Earth has it, it resonates from the core, the Ayin core, and so do these other planetary bodies, which function very similar characteristically as our planet does, the Earth does.
The camera, right? I mean, that could possibly cause it to give this effect that it would be larger than what it would normally be. We've seen a lot of comets tracking from Secchi. I have seen a lot of things come across on Secchi. I have never seen this. This is just, it's beyond pale of comparison. I mean, if you just do the math, so what would everyone say? Would we say that we're looking at what? I'd say 60-to-1 ratio, maybe more. But look at this. I mean, I've never seen anything like this. I have no explanations other than maybe this is a comet that fried Stereo B. I don't know. I mean, you can only come up with a few explanations. Look at this. Amazing. I mean, I'd love to hear your comments. And again, look what's happening to Venus down here. I mean, Venus is just getting, look at that, smacked. And you can see it reacting down here. Now again, I don't know where this is in relation to Venus, in relation to the camera. It's one of the things I don't know. But I can say this, we all can see this, is that the effect is just huge. So rational thinking would say, well, gee, I think that it's very close to the camera, but you can see our sun, how it's reacting to it as well. And then there's a normal CME. And then I'll close out with here. This was, again, another camera. This is B, in fact, how it was reacting. So I don't know what that was. We'll look at it one more time. So we'll just run this in real time and then close it out. Look at that, folks. Just amazing.
You know, something that's just stunning. It's beautiful. I've never seen anything like it. It really has got me, mashallah, very excited. Allah knows best what it is. I mean, it may not even be that. But just the possibility that it perhaps is just one aspect of an angel in terms of it's just one part of it, the wing part of the angel, SubhanAllah, and that the fact that if you understood the science behind this instrument and how it functions and how it works and the wavelength in which it basically receives data, then it's pretty remarkable, SubhanAllah. Anyway, Allah Subhanahu wa Taala knows best. I just really felt like I wanted to share this with everyone. Jazakallahu khairan wa ahsanul jaza for your time. Assalamu alaikum wa rahmatullahi wa barakatuh.